Does it work?
Yeah, you good.
Okay, fair enough. So if you can't hear me, please move forward. If I lose my voice, please move forward. I wasn't expecting to have to shout, so. Yeah, so, is it working? Hello? Okay, I'll try that for a bit. Okay, so machine learning has obviously become like an increasingly important tool for dealing with large data sets. And as that data continues to grow, so does the need for an effective and efficient way to process it. So AutoML promises that it can help with that by giving us a sort of efficient way to and accurately build models, even if you don't have much machine learning experience. Now, I'm assuming there's people in the audience with machine learning experience, especially since where we are. But obviously, not everyone has. It's a great way to get into it. So today, I'm going to go through SageMaker Autopilot, which is the AutoML offering from AWS. Yeah, so I'm Martyn Kilbryde, that's what I've been introduced. So I work at D55, which is in Manchester. We're an AWS partner. So you might have seen me around, spoke at ComSum last year. So let's say you work for an estate agency and you've got a database just full of houses that you've sold. So you've got all the details about the houses. You've got the actual price that it's sold for. So wouldn't it be great to be able to use that data so that you can predict how much a house is worth, so you can do valuations. So if you go into the database and you just do a dump of that data and you end up with something like this. You've got 80 odd columns, a lot of data in there. Now, it has all kinds of information. So we have the number of cars that fit in the garage, for example. We have the reason for the sale. So we have textual information, a classification of different data there. Plus we have the actual sale price, which is obviously what we want to predict. So at this point, I'm just going to try and jump in and do a live demo, which if it doesn't work, I do have screenshots, so wish me luck. Cool. So yeah, so you get to AutoML through SageMaker Studio. So if you've never used SageMaker Studio before, then when you come to this screen, rather than having an open studio, you'll have to actually create a domain. It's a very quick process. There's no cost to having SageMaker Studio. It's just using SageMaker Studio and the resources that it uses under the hood. So yeah, if you need to go in there, it should be quite quick. Obviously, you'll be able to Google how to create it, but it's a single page where you pick an S3 bucket and a policy. Now, SageMaker Studio is actually built in Jupyter Lab, which I only realized the other day, which if you've ever seen machine learning, it's generally in Jupyter Lab. So in here, obviously, we're going to go into the AutoML section. There's a lot of stuff in here which is really worth looking at if you've never used SageMaker before. So under AutoML, what we're going to do is we're going to create an AutoML experiment. This is what, and we're going to use the data I showed before. So let me just type in a name. So we need to give it a name. Can everyone see that, by the way? Is everyone okay? Or if you can't see it, shout up rather than the other way. Hope it's spelled right. So basically, we just need to select that data. So that file I showed you is just a big CSV file. So you need to upload it to S3 before. Obviously, I've already put it up there. So what I've actually done with that file, there was sort of 800 and odd rows in it. This is the data set that you can go and get from, I actually got it from kaggle.com, so it's an open data set. I actually took 5 rows from that file, and I've put them under a file called test. So right at the end, that's what we're going to use just to see how good it is at predicting. So with machine learning, you generally have 3 data sets. So you'll have a training data set, you'll have a prediction data set, and you'll have the test data set. And the test data set never goes anywhere near the algorithm. Otherwise, the algorithm could learn the answers, basically, and you won't know if it's very good. So we'll pick the training data set. And when you click it, it will give you an example of that data set. So you can just have a quick look if you want to. And then the only other option on here really that we care about is this auto split data, which should be default to yes. So this will, it does tell you if you click on there, but it will split the data into an 80% is the training data set, 20% is this validation data set that it's going to use for internally validating that the model is doing well. So it won't train on that 20%. Then we need to actually pick what the target's going to be. So this is what we're going to predict. So we could try predicting any of the values, but obviously we want to predict the sale price. And then the rest of the data here is just showing the different columns. In machine learning, they're typically called features. So you should be able to see the sale price is now not selected because that's not one of the features. All the rest are just default to selected. And the data type is auto as well. But again, because it's AutoML, I'm just going to leave it all as automatic. And then we've got the method that it wants to use. Now, again, I'm just going to pick auto because I'm trying to show that it's automatic. But under the hood, I believe if there's less than so many rows, like a few thousand rows, it'll do one, otherwise it'll do the other. So there's just two methods it can pick, but we'll just let it do that itself. And the final option is what we want to do when it's finished. So we can choose to automatically create a SageMaker endpoint. And that endpoint we can use for doing immediate inference. So we can send a list, well, JSON, to that endpoint with the list of features. And it'll instantly give us a prediction back. If you don't deploy that, you can deploy it later on. And you can also just use the model to do a kind of batch inference where you just upload a CSV and it'll predict. I will leave it as yes, but I don't think there'll be enough time in this talk to show that particular endpoint, but I have created one earlier. And again, I'm just going to leave all the defaults, so you can just choose things such as the size of the box you're going to use for the inference and them kind of options. So if you are going to deploy that, it will cost you. But also when you start this experiment, it's obviously going to create under the hood, it's going to be doing a lot of training, so it's going to be using EC2 instances. So the only thing that costs you at this point is when we start it, however long it takes to do that training, you're paying for the amount of resources that are being used. Now, in this case, it's about 20 minutes it takes. And I think I've done it about 4 times in prep for this, and it's cost me about £8. So it's not too bad, but if you've got a lot of data, obviously it's something that you want to double check before you run. And then I'm just going to create that experiment. So I'm just going to leave that to run. Like I say, it takes 20 minutes, so whilst it runs, I'll just jump back. And these are my screenshots in case it didn't work, so I'm just blasting through them. I did get a warning this morning that I might not have Wi-Fi, so it was just in case. So so the basics of machine learning, I'll try and cover a little bit of it just so you get an idea of what it's doing under the hood. Obviously, this is a very big oversimplification. So for those who understand machine learning, forgive if I jump over any steps, but it's just to try and keep it really quick. So the main thing really with machine learning, or generally you'll see a lot, is it's the data preparation. Ultimately, a machine learning algorithm is just maths. It's just a formula. So crap in means crap out. So you need to make sure that that data is prepared in the right way. So if we go back to that data again, as you can see, there's a lot of columns in there. And of them columns, how many of them are actually going to be relevant to the price? Some of them might have no relevance. Some might be really strongly relevant to the price, such as where the house is, the location, the size of the house, etc. So traditional data science would, do you want me to try again? Maybe not.
Test.
Okay, it's fine. You can hear me, can't you, anyway? So yeah, traditionally the first step would be to take that data, probably open it in a Jupyter notebook, start writing Python, and just looking at that data, finding out what information, what kind of links you've got between it, turning text into numbers and so on. So let's just look at a couple of examples. So these are 2 of the columns. So we've got the year that the garage was built, plus how many cars fit in that garage. Now, in this scenario, because they're both numbers, we've got an issue in that the algorithm is going to look at 2003 and then look at the number of cars, which is 2. And so there's going to be a greater weighting to the year, potentially, versus the number of cars. So as you can imagine, potentially the number of cars is probably more important to the price of the house. So it's things like this where you need to use normalization. So at the point of normalization, in this scenario, I've now changed them to between 0 and 1. So they're now on the same sort of scale. But then this raises kind of more questions, because what is the scale for a year? If you divide that by the current year, so you're going from kind of 0 to 2023, everything would be just 0.99. So in this scenario, I've actually started at 1900 to give a scale which is a bit more representative. But as you can probably imagine, there's a lot of decisions there around what you're going to do with that data. And the same with the number of cars in the garage. So at this point, I can't remember, I think I maybe said 6 cars is the maximum. So if a house comes along with 7, it would break the whole thing. So again, just them 2 examples, you can see where normalization itself could be a potential problem. Then looking at another column where we've got string data. So we've got, in this case, it's classification. So we've got the contour of the land that the house is on. So we've got level, banked, hillside, so on. So at this point, because it's text, like I said before, we obviously have a mathematical formula, so we need numbers. So we need to convert that into numbers somehow. So what we can do is we can pivot that. So now we have each one of them values has got its own column, 0 or 1, which is one hot encoding if you've ever done machine learning. And you have to do that to all them different text columns, which if you've already got 80 columns, you can imagine it's starting to get quite. And then you've also got the problem with missing values, which is a whole topic in itself. For those who've done the machine learning exam, you'll probably see it coming up quite a bit, where you can actually use a machine learning algorithm to fill in the missing values before you then use machine learning to do the actual predictions. But again, what you do, so looking at the year built, what you do is you just leave it as blank, because that might tell us something important. Maybe a blank year means something in terms of the valuation, because we can't guess the age. Maybe they've lost some paperwork or something like that. And if we take the mean year, then we end up with something that's a little bit of nonsense, because we have to then round it and decide what we're going to do in that scenario. And then for the text data, what do we do there? We can't take a mean. So do we take the most common value? Again, do we leave it blank? So hopefully you can see, obviously, at this point, we're getting to the point where we've got 80 columns and we're probably now up to about 300 columns, and we're getting quite complicated in trying to figure out how to process the data before we've even done much with it. And then finally, once you've prepared that data, you then need to pick an algorithm. You need to choose what you're going to do. Are you going to use a gradient boosting tree? Are you going to do a neural network? And as you can see from the names of them, you can't really tell what they do based on the names. One of them isn't even real, I made it up. So it all depends on the strengths and the weaknesses of each one of them. It depends on the data, basically. So you'd have to try different ones, potentially. You might have a good feel if you've done it for years, but it can be quite tricky to find the one that works the best. And then when you pick the algorithm, you need to then pick the parameters for the algorithm. So in case of a neural network, you'd have to pick the number of neurons, the number of layers, and there's a lot more than that. You've got learning rate and so on. So the premise of Autopilot is that you just give it the data and the raw data as well. You kind of export that data, import it in as a CSV. You pick the target column, like I showed earlier. It will then take care of kind of data preparation for you. It'll choose an algorithm, it'll try different algorithms. It'll do kind of optimization and training on that, and then it'll give you a leaderboard of the models based on how accurate, basically how well they are predicting, and then you can pick which of their models you want. But the one that does the best will be the one that gets auto-deployed. So let's see how it's getting on. Okay, still training. So what I'll do, to save you all waiting, I'll do a blue P to it. So when it's finished running, you'll get something like this, which hopefully you can see. So what we've got is we've got at the bottom here, we've got all the different models that it's built. and it's done 10 different models. And next to it, we've got the metric. So that metric depends on the type of machine learning problem that it is. So if you've got a binary, you'll have like an accuracy, which is a lot easier to understand because it's just between 0 and 1. In this case, we've got an error rate. So effectively, the smaller the number, the better. And the numbers are quite large because we're predicting a large number. But ultimately, this top one here is the one that came out on top. Now, what we also get is we get this data exploration notebook at the top. So again, you can use Autopilot even if you don't use the models it builds. You can use it just for the data exploration part, which is actually quite useful if you've ever had to try and figure out, looking at the data and try and figure out the patterns. So I'll just point out a couple of things on here, but there's obviously a lot in there. So you're given some total numbers at the top there, so you can sort of see missing values. So there's actually 6.71% of the rows don't even have a sale price, so we obviously can't use them for prediction. But we can see the data types and so on. But if we look down, we'll get things like, so the target column, which is the sale price, and we'll get some details on where that value is, roughly what kind of patterns we're getting with that, the median and all that kind of data on it. We can actually see some of the outliers as well. So we can see there's a couple of houses there that are very expensive. And again, you might be able to look at that and say, okay, we've got some rubbish data in there, and they can go back and export the data again. And then we've got a few things. So yeah, such as the correlation matrix, for example. Again, it can be quite useful for if you want to look at the data. So if we look at the garage area, for example, which I'll try and point with my mouse, hopefully you can see. So garage area to garage cars. You can see based on the darker color and the higher number that there's a correlation between the size of the garage and the number of cars in the garage, which makes sense. But what that might say to you is actually what's the point of having both columns in the algorithm because they're both related. And so again, it can start just for data exploration, so it might tell you something for your data. And we get things like missing rows. So we can see, for example, 99.52% of the rows didn't have a pool QC, which I'm guessing how good the pool is, which probably makes sense. But again, it's good for just looking at your data and saying, actually, I exported that wrong. And this notebook is a Jupyter notebook, so you can click into it and you can get to the actual code and use it as a basis for going on. So if I just go back, let's see how we're getting on. Still running. So if we I'll just pick one of these models. So for each of these models, you can click in and see the same kind of data. So the first thing we get in the model, and it will differ by the model, which can be quite interesting, is we'll see the feature importance. So you can actually see based on this, and there's a lot of scroll bars in SageMaker, so a bit annoying. So yeah, so the predicted column is sale price. So what this is showing us is which of the columns, which of the features are most highly kind of correlated to that sale price, have the biggest impact on that sale price. So overall quality is that top one. The next two are kind of the area that the house is. The ones below that are the size of the house. It's all the stuff that would seem quite obvious potentially, but it also shows that it's working. We can also look at some of the specifics around the model if we want. So we can see the instance type that was used to do the training. The one that's kind of interesting to me is the included model types. So what this actually did was an ensemble model where it actually used these different model types like XGBoost and even a neural net, and it used all of them and then took effectively the mean of all of them. So we've got an ensemble model, the best of all of them into one. And this is just one of the 10 models that we got given. Ensembling is usually the best way to get to get good quality results. We can also look at the performance. So some of these metrics can be quite useful, but if you don't know machine learning, which is the whole premise of this, then you probably look at MAE and think, what is that? So I'm not going to dig into too much of it because ultimately the MAE, MSC, and RMSE are basically just error numbers, so the lower the better. The R2 number at the bottom, though, is a percentage effectively. So you could sort of look at that and say it's 88%. Obviously we're looking at something that's potentially quite accurate. some of the graphs though, and let's see if I can scroll and fit some of this on. There we go. So yeah, so the graph's probably more interesting for what we're looking at. So each one of these little dots is the prediction versus the actual value. So we can see we've got a few outliers like this one where the actual value was 200,000 or around that, but the prediction was really high. So there's going to be outliers. Obviously, maybe there was some circumstances with that house we don't know. Maybe it was bad data. But as you can see, most of the actuals and predictions are all quite in line. So we've got a good model based on that. But you would have to be careful of the outliers, because if you look at that specific option, somebody could predict something that's double the actual price of the house. And obviously it'd be even worse if you predicted something that's less. And if you look at each model, you can compare these, and maybe one's better for outliers, but not as good in the center. And we've also got the residual plot shows the same data, but in a different way. So it's showing the predictions versus the actuals, but above the line and below the line, i.e. above or below the actual value. And ultimately, but you can download reports from here, so you can get kind of PDFs of this if you really want. Don't know why, but you might want to email it to somebody if you really want to. So if I'm going to check on this one I was running before, just out of interest, because it might have finished. Might make it more interesting. Yeah, it's not finished. Oh, we're getting some results though. So as the models come in, so it does the data preparation and then it starts running the models. So we've actually got 9 results. So there's one more that we're waiting on for this to be finished. But again, we can click in and we can see, and it's probably the best model will be very similar to the one I showed you before, because it's the same data set. So if we wanted to deploy one of these, like I say, we can auto deploy. We can also click to deploy from here. And at this point, we can do the batch prediction, like I said before, where we upload a CSV without the sales price of a load of data, and then it'll give us the predictions, and we'll get a CSV out. Or we can make real-time predictions where we'll create a SageMaker endpoint, and then we can call that endpoint using HTTP and get results back. Now, it takes about 5-10 minutes to deploy that, so you'll just have to trust that what I've deployed is basically this, because I don't want to wait around. But so if we go to endpoints, we can see the endpoint that I've deployed. So what we can do is we can hit it using SageMaker just to see how accurate it is. So I'll, don't want to do that. Nope. Let's open this. So the top rows in this are the ones that I said are held back. So these are the 5 rows, or 6 rows I should say, but these are the rows that I didn't include in the training data. Now the format that we needs to be sent to that endpoint is effectively all of that data, but in an array, a JSON array. So it's not very readable, but I've got a couple of examples, so I'll just take this first one and put it in. So hopefully you can see on there, we've got each of the pieces of data basically, so like the year that the house was built, for example, is in there. And if I send that, we get back a result. So the body of the result is just the predicted price. So it's predicting for that. It's really small text. I apologize, but it's predicting $211,193 in this case, because it's a data set from America. And if we go back, so for house 1457, that's row 4. So the actual price was 210,000, which is, about 1% wrong, which I think is probably pretty good. And I'll just take the other one of interest. And again, for this one, we're actually, we've been predicted 145,924. If we just have a quick look at that one, 1459, 06. That's 142,125, which 2 or 3%. It's not too bad. And obviously at this point, because it's an endpoint, we could start using that too. So if we want to say, actually, if this house was built in 2020, what would it make? And it's just dropped the price to 137,000. So newer isn't better, apparently. And let's go back. Again, screenshots, so I'll jump through it. But yeah, for the most part, that's kind of what I wanted to show you. So, if you have a lot of data, then you should already be considering machine learning. It's a very quick way of getting sort of more information from that data. But with SageMaker Autopilot, hopefully, as you've just seen as well, there's a very accessible way where you can just upload that file without knowing much about what you're doing, and you'll get some accurate models, and you can start doing it today. Thank you.